Hello, everyone, and welcome to this digital conference. We are going to wait a couple of minutes for more people to join us. So at this time, we will start. Thank you very much. Thank you very much all to be here, and good afternoon to everyone. Welcome to this East and Southern Africa Digital Relay Protection Conference. This conference is organized in 3 sessions, Part 1, Part 2, and Part 3. Today, we will start with the Part 1, led by Andrea Bonetti, Senior Application Specialist in Relay Protection Testing, based in Megger, Sweden. Next Wednesday, we will start with the Part 2, led by Stefan Larsson, Technical Product Manager for Relay Protection Testing, also based in Megger, Sweden, who will talk about the Sverker family. And next Friday, we will run the Part 3, led by Mario Spitzer, Technical Product Manager for Relay Protection Testing from Megger, US. The session will be about our SMRT family. Today, I would like to introduce Daniel Salate. He is the Sales Director of Africa, India, and Middle East. Hi, Daniel. I would like you to tell us about how Megger is structured and organized in this region to give the best support and services to our customers. You can get the lead now.
Thank you so much, Silvia, and also from my behalf, thank you so much for taking your time for today's session, hopefully also for Wednesday and Friday. Looking forward to that. So first of all, I just would like to explain that Megger acts global. Somebody asked me whether that's a typo error. In fact, it's not. There is a saying indicating that think global and act local. So global is basically a combination of global and local. And during the next couple of minutes, I would like to explain you our setup, our global setup, as well as our local setup. So can you press once more, Silvia? Yeah, thank you so much. So no, that's fine. That's fine. So as said, my name is Daniel Salate. I'm a Swiss citizen working out from Switzerland, taking care for mega sales into Africa, into India, and into the Middle East. So I'm frequently traveling to the continent, more or less about 4 to 6 times a year. In a normal year, of course, not during this pandemic situation where traveling is a bit more of a challenge. Can you press twice, please? Then we have our Megger employee, Alan Goodson. He's representing Megger in South and Southern Africa. He's based in Durban and taking care for the Megger sales into South and Southern Africa. 2 more clicks, please. Then the counterpart from Alan is Nathaniel Folscher. He's our application specialist. He's also based in South Africa, in Johannesburg. And Nathaniel is just making sure that those equipment which are supplied to our customers, that our customers are receiving a dedicated training, that they are able to take the utmost of the features offered by each and every Megger equipment. So it's here for the technical training on site. Then for the day-to-day business interaction between Megger and our local customer, we have regional partners taking care. Thank you, Sylvia. One of these regional partners is Coast to Coast Technology in South Africa. Then another regional partner also from South Africa is a company called SearchTech. Then we have for East Africa, Amotech, which is a Kenyan company taking care for the East African market. And last but not least, we have a company, Quasar. They are taking care for, let's say, our Indian Ocean business, Mauritius and the Seychelles. So that's just in a very brief way and in a few words, the global setup from Megger as a multinational company, and then our local setup with the different individuals being there for you for the day-to-day connection. That's it from my side. Thank you so much, Sylvia, and please enjoy today's seminar. Thank you.
Thank you very much, Daniel, for this information. Is very useful for our customers. And at the end of this presentation, you will see the contact details of our Megger offices and official partners as well. As well, I think it's very important to highlight where is Megger looking forward in the protection area. And the best person to explain that is our Business Development Director for Protection and Transformers, Niklas Weatherstrand. Many thanks, Niklas, to be here, and when you can explain.
Yeah, thank you, Sylvia. So I'll just have a very short presentation here, 2 slides talking about a few subjects. So I'm also based in Sweden as Andrea and Stefan, but I have a global position, so I care for the protection business, which means relay protection, circuit breakers, and instrument transformers, basically. If we talk about the future, and what we hear of a lot is, of course, smart grid, and that is also something we hear and look into a lot, where we see the smart grid going down in voltage levels. And next, please, Sylvia. The smart grid will, of course, communicate and take own decisions. It's a more distributed generation, preferably renewable energy, and so on and so forth. A lot of IT systems is coming into our world where we had copper wires before, so digital things. Megger have focused at a few areas within these smart grid applications, and possibly you have seen the last year or so where we have communicated a lot around distributed generation. So that will mean wind farms and solar farms and testing of those. And that is no difference for relay protection. As we know, there is a lot of self-power relays out there now with the smart grids, because you need something that is digital but still very basic protection level, so not expensive, and that's where we see growth of those. And those have challenges to test, so we have things there you can look into. As you see there to the bottom right, we do have on our website parts of or targeting these areas: smart grid and digital substation, and smart grid and distributed generation. The digital substation stuff will be more in focus this year, where we will see a lot of different product releases and assets, applications, I should say, that where we will come out and communicate around during the year. So keep your eyes open. Next, please, Sylvia. And next again. So international and local influence, you can go one back, please. We are active in different ways to both keep ourselves informed, but also the industry informed of what technologies and what we can do for the industry. So we are active in standards and committees around the world. So I'm sure you heard of more or less all of these, where we have participants actively creating standards, where Andrea Bonetti is one of them in IEC, for instance. Next, please, Sylvia. Then, of course, we cannot be in this industry without having a tight cooperations with those who manufacture and develop these assets that we are testing. So we are cooperating tightly with more or less all the manufacturers. Just stated a few in here, but all the larger ones, and also in some countries where you have local smaller ones, we are many times in cooperation with those as well. Next, please, Sylvia. If we look into partners, where we are partnering also with the transmission distribution organizations, I just took a snapshot. This is, of course, not all, but just to show the broadness and that we are working already with companies within your regions. Possibly some of you are from these companies, and also around the world, from Europe, from Asia, from US or South America, Latin America. So we are everywhere and working locally with all these, just to ensure that we do as much and as good as possible we can together, so to speak, and utilize our instruments. So with that said, I'm happy to hand over, Sylvia.
Thank you very much, Niklas. It's very important information to consider. Right now, having clear how Meyer gives support to their customers in these regions and the focus that Meyer has in this area, we are ready to start with the digital conference part 1. Maintenance activities of electrical substations with focus on the secondary protection system by Andrea Bonetti. Andrea Bonetti, Senior Application Specialist in Relay Protection and IEC 61850, Master Science in Electrical Engineer at La Sapienza, University of Rome, Italy, has also 12 years experience as a specialist at ABB, High Voltage Relay Protection Manufacturer, Västerås, Sweden, 7 years of experience as a specialist in test equipment and tools for protection relays at Meyer, Stockholm, Sweden, and 5 years of experience as consultant for TSOs and DSOs in Scandinavia and UK for AEC 61850 for protection applications. Also, Andrea is active member since 2006 in the AEC committee responsible for protection standards, which is the TC95. Andrea, he is also based in the factory of Danderyd, Sweden. In my case, I'm Silvia Paulino. I'm the Marketing Operations Manager for Europe and Africa, and I will be leading monitoring this session. And as you can see in your right hand box highlighted in red, you can read your answers. You can put your questions there, and we will read your questions at the end of this session. This meeting is going to be recorded, so you will receive a copy of this webinar to see it again or to share it with any of your colleagues. This is the agenda for today: maintenance and commissioning today and tomorrow, importance of the substation documentation, outsourced maintenance versus in-source maintenance activities, smart grid, renewable generation, challenges transformed into opportunities, equipment provided by MEGR, and the importance of the technical training and support. So thanks, Andrea, in advance, and I pass the control over to you.
So thank you, Silvia. Thank you very much, Silvia. Thank you very much for all of you being here. I need a sort of feedback. Silvia, can you see my screen and can you see me, or is it okay? Can you hear me?
Yes, we can see your slide and we can hear you very, very well.
Okay, thank you very much. So as I say, thank you for all of you for participating here, and we will try to go through the agenda that Silvia has proposed right now. Let's try to see if the technique works. Yes. So all of this has in principle to do with the digitalization of the power system. So what do we do when you do commissioning, maintenance? If there are any challenges and possibilities, and what can we do from the inputs we receive from the standardization? What we have now, and maybe I can also try to see what we have next. So where do you want to go? Now, please have a look at this. I hope you can see, maybe Silvia can confirm that the movie is visible.
Yes, the movie is running perfectly.
And I challenge you to guess what stopped. What this could be. It's moving. So this is a power line. Actually, this is a power transmission line. Was a power transmission line. The question is, would you use the same maintenance methods that you use for this line that was used for this line? For this one, they are both power transmission lines. So the issue is how to address a new technology. Methods and procedures that we used in the past, and today could be the past of tomorrow, it is the past of tomorrow, cannot always be directly extrapolated from the older technique. New methods will allow to achieve the same goals of the previous methods. It's necessary to understand the purpose of the previous procedures, so why we do something, and see how the new technique can be used to get the same purpose. So we have sometimes, we cannot say, I do like this because I always done like this. We have to understand why we do like this to be able to reach the same goal. And somebody said also we have to look outside of the box, or we say if you always do what you always did, you will always get what you always got. And this guy was not a normal person, was Albert Einstein. So again, it's necessary to understand the purpose of the previous procedures and see how the new technique can be used to get the same purpose. And let's start to see what we do when you do commissioning tests and what we do when you do maintenance tests. Commissioning tests we do to set up the system, to make sure that the system works. And we test the devices, we test ourselves, we test our settings, we test the customer, we test a lot of things to make sure the system works. And out of this number of tests that we do for commissioning, then we have a subset that we use to verify that the system is still working. So that is a maintenance. In Latin, maintenance also actually means make sure that the system still is maintained, continues to work. So they are a subset of the commissioning test in principle. And how does the flow chart, if you can draw a flow chart, work? We have the maintenance test, we perform them, we get a question, is everything okay? Hopefully yes. If we get everything okay, good, finished, no need, I don't have to open the box, I'm happy with that, it's still working fine, finished. But if the answer is different, if the answer says, no, it's not, everything is not okay, there are some issues, then we need to have a sort of investigation to understand what's going on and why. We need to open the box. And then we have probably to repeat some commissioning tests because we have to repair what is going wrong, we have to fix it, and we have to verify that it is working. So the commissioning tests are more complex, I would say. Again, commissioning, make the system working, maintenance, make sure that the system is still working. So this is the basic, and some considerations about maintenance. How many times do we perform maintenance tests on a system that is working fine? You do the maintenance test, and everything is okay, and the customer tells you, I knew that, but you did it. And how efficient is a periodic maintenance test, even if some failures are found? Let's have a look at the number 2, because the number 1, there are some obvious answers. Let's have a system. This is my substation. It's working fine. I do my maintenance test, it's okay, it's passed, the system is working fine. Then somehow it gets a failure. I have the system faulty. It depends on how serious is the damage. Maybe I don't see it. And the next time I do the maintenance test, I can find out that the system was faulty. I do the repair actions. And after the repair actions, the system is working fine. That is quite normal. It happens every day still today. And we do some more formal calculations. Let's say the mean time to repair is the time where the system, the system needed to be repaired from the failure to when I repaired it. And we have also a statistical formula that is the availability of my protection system, or in this case of my system, but now I'm talking about the substation, is the mean time before failure or between failure divided the MTBF plus mean time to repair. So if we bring down this number, the mean time to repair, to 0, eventually, we go to 1. So no matter how much the system gets broken, we can increase the availability. For the other one, why we test the working system that is already working, obviously, we are never 100% sure the system is working. So we have some feelings that it's working, but we are not 100% sure. That's why we test it periodically. We want to be able to document that the system was tested. In case something happens, you get blamed. We cannot even afford to do maintenance tests on a power system every week or every day. Of course, we have to schedule at the regular intervals, maybe every year, every 2 years. It depends on the technology used in the power system. So periodic maintenance tests of our relay protection systems are done and will be done for many years. But now we have to look into the digitalization of the electrical network, and we go rapidly into a new standard. No, it's not new standard, but for many people it's new, which is called IEC 61850, which is the international standard for the, I can say, it's my words, for the digitalization of the electrical network, which means at the end, smart grid. The 6150 standard is one of the core standards for the smart grid, according to International Electrical Committee. If you go to the IEC website, you can find the definition of, you look for smart grid, and the smart grid is defined in the sort of core standards And the power utility automation IEC 6150 is among the first 7 core standards of the smart grid. Now there is even an article on the homepage updated recently that is talking about what I'm saying, and is explaining with other words in mind that IEC 6150 is important for smart grid. In principle, let me say, if you do smart grid, something that you can call smart grid, without using IEC 6150, in practice, you are not doing smart grid according, again, to IEC vision. And this could be one point for you to take a note for, in case you are asked why are you using 6150, well, because I'm doing smart grid. It's quite obvious that it has to be like that. Now, we have the 6150 substation, which is a principle, a standardized numerical electrical system. What can we do to verify that the system is running well? So maintenance. Well, if it is a numerical system, why don't we use a numerical technology to get information numerically, reading data, communication about the state of the system, and get numerical solutions, comparisons, algorithms to assess the status. So, sorry, the idea is to select the parts of the system that are most important, that give me an idea how the system works, and compare the previous proven status with the current today's unknown status. If it is equal than before, and if before it was okay, and then before I use it as a master comparison status, I'm fine. When there is a difference, I give an alarm, and it's the maintenance routine has failed, they found an error, somebody has to open the box. And if you do this automatically, periodically, but automatically, once every day, once every week, once every hour, depends. When we implemented this automatically, we perform the so-called self-supervision procedures, automatic maintenance procedures, event-driven maintenance procedures. Everybody can give them sort of different name, but they are all meant to do that. The system automatically gives you a warning. Say, yeah, if something is wrong, I'm sick, I tell you I'm sick, I need a doctor. So the doctor only comes when we know that there is something that we have to investigate. This is the basic idea of maintenance, automatic maintenance procedures. Difference between the two approaches, let's have a look. Without self-supervision, let me call it self-supervision of the substation. We have maintenance test, the system was okay, now we get a failure. In the self-supervision, we have no warning, so the system is okay, but now we have failure at the same time. So we have automatic warning. In the first case, we do repair actions, and after that, the system is okay. But in the first case, we have the system still faulty. Until we do the next maintenance test, we find it out, we repair it, and then it goes on. What's the difference between two? The mean time to repair. So the repair action has shortened the mean time to repair. Call it also event-oriented maintenance. The availability, again, of the system is the mean time before failure divide the mean time before failure plus mean time to repair. If we put it down, to 0, availability goes up. If we reduce MTTR, availability goes up. So there is also a sort of implications about having the availability of the system, not only for you that maybe are owner of the power system that you want to sell your energy, but also for me that I would like to consume the energy. So availability of the power system is very much related to availability of the smart grid. Now 6150, how long have we been working with 6150 Mega? Well, since 2008, which is quite a lot of time. First product and software tool developed for 6150 Mega were released in 2009. Every year we work in implementing the new concepts of IEC 6150 in the test tools and devices that we have, because 6150 is alive, it evolves. Edition 1, edition 2, edition 2.1, all the new concepts must be implemented and carried on. And then we also not only work on the final products, but we also work at our pure R&D level with the universities, where we develop some ideas for the concept for using 6150 for related testing procedures. So the ideas I mentioned before, we have written some papers, we've done some studies with university. We have not put them in place, but there are some feasibility studies that can be done. Some products, I will go very shortly because you will see this more in details on Friday. In this case, we have a goose sniffer. So goose is a message and sample value messages for 6150 that they can be done from computer, like the majority of the offer on the market, but we can have them on board of our hardware test equipment. So this has a cybersecurity implication, which is quite strong. We have test sets for sending goose and receiving goose, sending sample values and receiving sample values, so we can do testing with the so-called process bus protection relays. And the idea of the comparison we have implemented several years ago. It's an idea to compare what we see on the network, what we read automatically from the network, with what is a master file that describes the network. So this comparison is done automatically, but the comparison must be done manually by the user. So we are not implemented automatically yet. If somebody wants, we can really implement it and start to do these things in a serious way. So what should I do if there are some final users I know here? What should I do as a user? Well, for the first thing, I have to say, use 6150 standard. Specify how you want to use it. And for example, in this case, specify that you want to be implemented some supervision algorithms. And also follow the standardization community. For example, my technical committee, working group, technical committee 95, working group 2, is now writing, since I think we started 3 years ago, a technical report about the use of IEC 6150 for power system protection applications. So really testing, really power system protection. Its name is 6255-216, will be ready by 2021, and I guess probably will be 2022. The idea of this is to provide you with a wide competence on how to use 6150 for protection applications, so that you don't have to write number one, use the 6150 standard specification by yourself. You can really pinpoint to this document. So please follow the IEC community, because this is a very important document that is under project. A few words about the dilemma between insourcing and outsourcing. I've been working, as Silvia said, quite many years as a relay protection manufacturer. I met probably all the TSOs in the world, not all, but 90% of them. And I've been facing the situation of from insourcing to outsourcing. And also I see now that we are going back from outsourcing to insourcing. What are the key points here? Insourcing in the short term is a good solution. It's it's a expensive solution because you have the people in the house and you have to pay them even when they don't have to test the substation. So in some cases, it's seen as an expensive solution. Outsourcing, instead, you send them out and you buy them at the time when you need them. So in the short term, it's a cheaper solution. In sourcing, we have that the competence remains into the company. We have the expertise and the knowledge of the system is available in the company. So we have a faster and more reliable test. We have specialized competence, which is available when needed, even if unexpected. On the other side, the consultants must be booked in advance. Maybe they are busy. Actually, hopefully, if they are good people, they are heavily busy. And the consultants, external consultants, need anytime different people need to learn how the system works. So they don't know your substation. They don't know all the tricks in the substation. Your competence, key competence, is outside the company. If we go back to insourcing, it allows for a minimized documentation because yeah, they know the system and they are part of the system, so they don't need to be explained on everything. In outsourcing instead requires a more complete and simple documentation that can be understood by many people. Information about power system are kept inside the company. If there is a problem which is important to be fixed, they are your people and they talk to your people and they fix the situation inside the company and nothing goes outside. When you have people from outside instead, you have always the risk that they see things you don't want to see, and I fully respect that. So the communication is never crystal clear. Could possibly is not crystal clear. Many TSOs and DSOs in the world are now reconsidering insourcing after many years of outsourcing. But insourcing after outsourcing is complex because you have to reestablish the competence. And while instead it's easy to from outsourcing to insourcing because you say you send them out and then you buy their time when you need them. So probably the truth is in the middle, and that's my opinion, of course. Between insourcing and outsourcing, keep the core competence inside your company, keep the core competence inside the company, create an internal team with the function of supervising and cooperating with an external team. That can be done of different people every year, but the core competence is inside the company, so that they cooperate, they supervise, and they work together when you do testing, so that you keep the advantages of both situations. You have flexibility of outsourcing, but with the competence key role of insourcing. And actually, several TSOs and DSOs are going into this direction. I've been requested as a consultant to perform activities in training this new team inside the company. And clearly, the question is, you need to have the right competence, not only the tools. You need to know what to do with the tools and equipment. So training and competence is a key factor in trying to have this core department, I would say, expertise, department of expertise into the substation that you didn't have before, or into the company. So for the training point of view, we in Sweden and in the Dallas, we are the two centers of excellence for the relay protection testing. I apologize for this mistake. We are cooperating together for everything, for product development and also training. So we have many specialists that have many years of experience in the power system protection. We don't know only our tools, because we have done them, of course, but we also know the power system protection itself. We can do train the trainer, we can do train the user, final user, we can train the final user together with the trainer, local trainer, or both. You decide and we fix the training. And we have a good experience with AVO, which is a training institute by Megger, which is now celebrating 55 years of experience in training the electrotechnical community. This is an American, more known by the American market. We are not in Sweden, but we can easily cooperate with them. So no issues for competence in delivering training from us to you. Also, remote training is now good. And also, we are writing papers, technical notes, any type of possible technical literature for you. Just write an email to me or LinkedIn connection, whatever. We have many of possibilities. We have many of technical papers that can be used for you as a reference, even at the peer-reviewed papers at IEEE level. So, just one step back. What did I say? If you use outsourcing, you need documentation because the people don't know your substation. How important is the documentation in a substation? Yeah, who knows if they have breaker failure here? I can't find it. These two guys are new, they've never been in substation before. And then one has one idea, let me just try this, and puff. It's dark. It's not only dark into the PowerPoint, it's really dark. So at this point, what happens? Some mobile phones start to ring within a minute because the control system has seen that. Breaker failure protection actually was there, but it was very well hidden. This is a major risk related to outsourcing. Specialists don't have a good comprehension of how the system looks like. They are also time pressed. And a short of comprehensive documentation where the most important information upfront should be desirable, but we don't have it. Again, 6150 standard comes to help. The numerical technology is standardized, so the technical committee 3 is working now on a document for representation of the communication power utility automation. And the purpose of this document is to allow an engineer not familiar with the substation to easily get upfront information about the communication structures. And communication structures is the current from the current transformer to the relay, because now it's a communication data. So the trip from the relay to the breaker is part of the communication structure. So once this is described in a very easy way, you have a page, a document of, let's say, 30 pages where everything is there. The most important things are there, and you know if you have something or not. You know if you have breaker failure or not. And also you know where to get more detailed information of breaker failure. I think that this is very important, and TC3 is doing a good job. I was also part of this committee to write this part of the standard. It will be not a standard, it will be a technical report. Make a note. And will probably the publication date will be 2022. It's already done. It is out for comments, and we have for sure to review all the comments and fix for vote. So if we step back and we again look at the smart grid and the protection of the smart grid, you see I'm looking the smart grid from very different point of views. It's an electrical system, and we have to protect it. On the other side, if you want that my electrical system, the smart grid enters at every voltage level, so my solar panels that I unfortunately don't have on the roof of my house, if you want me to do this, I want to have it simple and cheap. I cannot test my solar panels every year. No, it's expensive. We will not do that. So, and at the other side, when we do the protection of this system, that must be simple and cheap. We have to manage the protection. We have to make sure that the people and the assets are protected, and we have to make sure now also that the stability, for example, frequency stability, is kept. It helps to keep the frequency stability. And these 2 points I want to touch a little bit. Self-power relays, they are there for this year. Just some example of some known vendors. They are digital relays that simplify the protection system because they don't need a battery system with the DC network, etc. So they take energy to work, they get it from the load currents or eventually from the fault currents. So they simplify very much the protection system. They increase the reliability of the protection system because they don't need a DC voltage to be run. And they are everywhere in the wind turbine generations. Everywhere, no, but very often are they there. If you look at Ormas Abad, I have to say thank you for this slide. They are using self-power relays in the majority of their medium voltage wind turbine generation. And they have found out that they increase the mean time before failure of the system. But they are the nightmare of the relay test sets because I give you the load current, I give you the fault current, and to this current I must give you the energy to power up the relay. So you can understand they are tricky. And we have Sverker 900 with the new current generators, Mark II, that are being designed to manage the testing of self-power relays. Then we look at power system frequency. And here you see a beautiful movie. I hope you can see here smoothly. A beautiful movie where each ball has its own steady state frequency. and how these interact together. I think I would never stop to watch it, but I have to go on. And in one slide, I have to tell you that the frequency of the power system is related to the balance between the energy that you put into the system, produce the energy, and the energy you consume. And we have had it also this before, of course, but now with the zero inertia generation, like zero mechanical inertial generator, like aeolic wind turbines, wind farms, and solar panels, and battery storage as well, they have the problem that they are reducing the mechanical inertia of the rotating masses because they don't rotate at all. So they are the inertia damps the frequency oscillation. The frequency is actually the speed of the rotation of the generators. The new renewable generation is also affected by weather. So in few minutes, I can lose one complete city of solar panels, and in other few minutes, they come back. So I cannot shut off and shut on all the loads only because I have the cloud on Stockholm. So all of this means that the system must react, must talk together as much as possible, as soon as possible, and try to counteract this even by putting in some energy, for example, with battery, etc. Well, we cannot go into these details today, but the idea is that we have larger frequency variations. And it's not a big problem. We are working on that, of course, but we have larger frequency variations than before because of zero inertia power generation. And since this is important, frequency is important aspect of our power system, there is a new standard from IEC, it was 2019, that has been created because of the most, it was recognized frequency and ROC-off, rate of change of frequency, as the most important protection functions for smart grid applications. So in 2019, from 2019, there is a new standard, February 2019, there is a new standard on frequency and frequency-related protection functions, 61, 6255, 181. And many people know about this, and many new features are there, and especially many concepts are standardized. One of the things that has been standardized is the meaning of variable frequency. How can the frequency change, and that the frequency changes still because we have rotors that are accelerating or decelerating, and this is a standardized waveform that we have to apply to frequency relays and to rate of change of frequency relays. Forget about the details, it has been standardized. And the frequency ramp, as we call it with the popular language, is to be smooth and cannot be done in steps. That's the principle, one of the most important principles established by this standard. There are many others. And the knowledge about the 6255, 1281 is growing very fast. You can just Google search for it, and you find out Australia that said, okay, all the protection relays must be type tested according to 6255, 181. Even the small ones that you have in your cubicles at home. If you have a frequency relay at home at 230 volts, it has to go through the type test according to 6255, 181. So if we will find that these relays more and more everywhere, we should test them according to the standardized methods, even if you do commissioning. And also we have commissioning engineers or consultants around the world. This is one I found casually on LinkedIn that says, I'm testing the relays, voltage, frequency, ROC-off, vector shift, negative voltage, I guess, according to 6255 series, which I contacted this guy and I said, why? It's interesting. Why are you offering this type of job? I said, because my customers are asking for that. So customers are asking to perform tests in standardized methods where it is possible. And we have, again, Sverker 900, but we have also Freya and SMRT for other reasons that are ready to test the frequency ROC-off test according to the new standard. So of course, the new standards have impact also on the test sets. Try to use test sets that have as much as possible standardized methods, even for commissioning. Here, switch gears, low power instrument transformer. They were called, time ago, they were called non-conventional instrument transformers. And then they changed the name into low power instrument transformers, because if you continue to call them non-conventional, nobody will use them. So probably the change in the name was a good change. Rogowski is a typical one. There are many others. Well, there are several differences that are important for relay people. They are smaller instead of larger. They are linear, much more linear than normal current transformers. By the way, we know how to handle the current transformers, so don't be afraid. I don't want to say use always Rogowski, but there are a lot of reasons for using Rogowski. They are relatively cheaper, they are smaller in dimension, more linear. They are probably for several current ranges more accurate in a steady state measurement. And they are an interesting candidate for sensor in smart grid applications because they are small. It is definitely a new technology in power system protection. There are, of course, problems behind this, the transient response, etc., but we're working on this. So Rogowski or low-level sensors are an interesting candidate for medium voltage switchgear, and they are used more and more, by the way. So it's clear that we have to work with that, especially for Rogowski. We have several ranges, and we have smart SMRT and Freya test equipments that are available now for testing through Rogowski voltage amplitude. So we inject some voltage signals instead of injecting a lot of current signals, but we can manage all the three ranges: 2 voltage range, 10 voltage range, 40 voltage range. I want to say more than that. You will see this on Friday. And this is now digital twin. I cannot talk very much about that. There will be a new article soon on our electrical tester, but we are ready and we are developing. It's never ready, this technology, but we have developed a digital twin test set that is able to talk with a digital twin relay. Digital twin is a software copy of what the relay does in the reality. So our digital twin test set is a software copy of what this guy would do. And when you save the files in the digital twin world, you can reuse it in the real world. There are a lot of benefits behind using digital twin testing. These are all the test sets we have in digital twin world. We connect to our virtual test set, and we run the test, and we save the file, and we use some of those files in the substation when the most important tests, the connections, etc., can be done. So we can see that commissioning tests in substation might be a subset of the commissioning tests that I've done virtually. Very, very interesting.
Hello,
and
Andrea.
here you see how it works. So
I don't want.
I'm ready. This is actually the last slide. So this is how the digital twin in Siemens works when connected to our digital twin imager. As I said, we have our electrical tester magazine, where we have a new article. It's coming. So more than that, I will not say, but stay tuned, and you will have new information about that. So actually, I'm ready. I hope I managed to give you an overview of what we are doing on this international group, and I'm ready for your questions. And thank you, Silvia, for jumping in.
Thank you very much, Andrea. Sorry for interrupting you. It is
no,
very
absolutely not.
Thank you very much. But we have a couple of questions, and they are very, very interesting. Like,
sure, I cannot see them, so please, can you? I don't know, guys, if you see me now or not. Okay, I can hear you, so tell me.
We are looking at your hand in your presentation.
All right.
Okay. The question is, what is the frequency of maintenance testing of numerical relays for non-IEC 61850 substation?
This is I cannot answer this question because it depends on the owner of the system. You have a digital relay, and maybe we can say, yes, the digital relay, no matter if it is 6150 or not, you can test it every 2 years because the digital relay has supervision, etc. Fine, but the digital relay is connected to the breaker with an analog circuit, is connected to the current transformer with an analog circuit. So philosophically speaking, the analog circuit can get broken anytime. The trip circuit can get broken anytime. So this is what is giving you the demand on your testing your protection relay. The relay, maybe you could maybe you could also say, I don't test it if nobody has changed anything. But it is natural, it's very common that main 1, main 2 relays, for example, have voltage systems can be, say, main 2 I test every 2 years and main 1 I test every 2 years, but shifted. So every year you test main 1 or main 2. As I said, you have to consider your power system when you take this decision. I can give you only some information about what the other people do, but in general, you have to consider you have still an analog system behind this digital relay. So I cannot answer 100%, but I hope I gave you some hints.
For sure. For training, do you offer online training for end users?
Yeah, we can. We are working on that, both in Sweden and in the United States, in Texas. So yes, we can offer training, and we can offer training on purpose of what you want. Might take some time to do dedicated documentation for that if you have special requirements. But yeah, we can offer online trainings, of course.
Okay. I have to say that I have many questions asking for demos,
Wow.
more information. Yeah. So at the end of this session, you will have the opportunity to complete a survey. For us, it's very important to improve our services and our style to connect with our end users and partners. So please fill out the survey, and then you can have the chance to ask us anything that you need. It's a demo, it's a quote, it's a technical support, whatever you need, please complete the survey and we will get back to you very, very soon. We have, yeah.
No, go on, sorry.
No, it's fine. Go on, Andrea.
If there are questions that we can answer by mail, I mean, you can just forward the questions to me. I don't know. I don't know why I don't see dashboards. Or where are the questions? Chat, polls, where are the here questions? If there is an email around, yeah, it's very small. I cannot read.
Yes.
If there is an email around, I can answer, or we can try to answer Wednesday and Friday.
Yes, for sure. It's very important as well for all our attendees that don't miss part 2, that is next Wednesday at the same time. It's very important because, as Andrea said, we can bring your questions from part 1 and even have more questions probably from part 2. So we will be there to help you in any case. As I said before, at the end of the presentation, you can see all the contact details of our official partners in East and Southern Africa. So right now we have 2 minutes left. And if you have any question, please do so. And thank you very much. I will share the link of part 2. It's already in the survey. So once you complete the survey, you will see the link to the part 2. Anyway, if you don't find it there, you can see it on our website, international website, megger.com, and you go to websites and you find in the list the 19th, the next Wednesday, 19th of May, and you will see the session there, the link. So you can register there. Okay, so I have to thank you, everybody. Andrea, especially, there are congratulations in our chat for you from the attendees. Thank you very much.
I don't see anything. Nothing.
Yeah, is there. And thank you very much, Daniel, to be here supporting us in the field with your sales team and technical support team as well. Thank you, Niklas, for the focus and understanding of Megger in this field that is very important for the people that is working in this area. And thank you all to be here. We really appreciate your time. Thank you, and we will see you next Wednesday in part 2 and next Friday in the part 3, concluding this digital conference. Thank you very much. And please don't forget to complete the survey. Thank you.
Thank you to all of you. Thank you very much. Thank you, Silvia. Great job.
Thank you.
Thanks, everybody. Bye. Have a great day.
Thank you.